All right, so this one here, I believe this says g of x equals, I think that is a 2, and it looks like that is an x plus 1. So I'm going to just think about the two big things here have to do with where the asymptotes are. The denominator tells me the vertical asymptote, and so I know that the vertical asymptote for this one would be x plus 1 equals 0. You set it equal to 0 to see when that denominator would be 0. If the denominator is 0, it doesn't exist at that place. So we set it equal to 0. I would subtract 1 from both sides, and I would get x equals -1. So this would be the vertical asymptote should be x equals -1, which would be right here. Okay. Notice it's not there. It's moved to the right. It looks like it's right here now. Okay. So instead of being at -1, it should be at +1. Which means that this would have to be, instead of being x plus 1, this would be x minus 1. Now, I don't know exactly what she's asking for you to do here. Describe the transformations. It may be that it is shifted right 2. Okay. Could be shift right 2. It could be that she wants you to actually have x minus 1 in the denominator. Okay. You'd have to ask her or reference some of the examples that you've had from these questions to see if she was wanting this or if she's wanting how it was shifted. The other thing that I need to look at here, and let's erase that. The other thing that I need to look at is the horizontal asymptote. To figure the horizontal asymptote, you look at the degree. Degree of the numerator is 0. The degree of the denominator is 1 because we're looking at the variable's exponent, right? Since there's no variables, that's x to the 0 power, basically, x to the first power. So since it's smaller, then we know it's just going to be 0, okay? So what I'm going to do here is I'm going to say, well, let's see here. Is it at 0? Well, if it was at 0, it'd be going right across here. But it's not. It's up here at, looks like it's up here at 2. Okay. So since it's shifted up 2, that means I also know there should be a +2 after this. From what I can tell, nothing else has changed here. I know that I've got the 2. Now, the one thing that I'm not for sure about, but I'm pretty sure that if it goes this direction, it's still positive. You'll have to double check. I think that if it's goes down and then down this direction, I don't remember if that's a positive or a negative in the front. I feel like it could be a negative. But you can always plug that in on your calculator and try graphing this and see if this looks approximately. That's one of the nice things. You can always grab your calculator and try that. Now, I know that you can't see my calculator, but I will show you something here in just a minute. I'm going to plug that in on my calculator. Let's see here. So I would have to, I'm going to plug in basically this and see if it looks approximately like that. This is one of the nice things you can do. So I've got 2 divided by, let's see here. Let me go back actually. I've got 2 divided by x minus 1. Close that up there. And then a +2. And then I'm going to hit graph. Okay, so now, first of all, let me show you that. So this is what my screen looked like. Notice to get the 2x minus 1 as 1 unit, I did parentheses around that. The x minus 1, the denominator, I put that also in parentheses so my calculator would understand it correctly, the +2. When I then hit the graph button, it looks like this. And so that's pretty good. That's pretty much what that looks like there. And so I would say that this is precisely what we did. So we shifted it up 2, we shifted it right 2. But here's a possible k of x equation that would work for this. But like I said, one of the nice things is you can always plug in an equation into the calculator and see if it actually looks the way you think it's supposed to look. Usually it doesn't take too long to plug that in real quick just to do some checking. Okay. Hopefully that's helpful.